This video is about finding the rate of change from a table, graph, and function rule. So today we're going to use graphs and tables to determine Terrence's rate. The most important idea from today's lesson is that rate can be found from both representations. So in the first one, we're given a graph, and we need to describe Terrence's rate for each part. So we're going to describe not just by number, but what it means. So in the first part, if we want, we can call this A and B. So in A, he's moving away from the motion detector at a faster rate. So we're going to say A, we're going to say what he's doing, moving away from the motion detector at a fast rate. Then we're going to find what the rate is. So in this case, we need 2 points to find the rate. So we know to make our little triangle, we went up and over to the right. So we went up 1, 2, 3, 4, 5, 6. And we went over 1, 2, 3, 4. So our rate then would be 6 over 4, which reduces to 3 over 2 feet per second. And it should be positive because our line is going up. And then in B, because it's a flat line, that means he's not going anywhere, so he is standing still. And if you're standing still and it's a flat line, remember it's always 0 feet per second. So we need to fill in the table below using the animated graph from above. So we have 1, 2, 3, 4, 5, 6 spots. So we're going to do, let's do it 0 seconds, 2 seconds, 4 seconds, 6 seconds, 8 seconds, and 10 seconds. So at 0 seconds, he's 1 foot away from the motion detector. At 2 seconds, he's 1, 2, 3, 4 feet away. At 6 seconds, he's 1, 2, 3, 4, 5, 6, 7, and then he stays at that distance away. So 4 seconds, we said he's at 7, and then every second after that, he also stays at 7 feet. So what is Terrence's rate from 4 seconds to 10 seconds? So using our table from 4 to 10, we're going to look at these two numbers. Well, he's changing from 7 to 7, which means he's having no change, positive or negative. In the x-coordinate, he went from 4 to 10 seconds, so that's plus 6 seconds. 0 over 6 is equal to 0 feet per second. Why? Because he's standing still. Will a horizontal line always have a rate of 0? Yes. So the summary, to find the rate of change, we do the change in y, which is always the column on the right, divide by the change in time. Remember that our change in time is x. So we could also say that y is the change in distance. So from a table, we do the same thing. We're still doing the change in y over the change in x. Remember that we can also count and go up or down on the graph and then to the right. So below, though, this graph is a little bit different because in this graph, the rate is not constant. Because it forms a curve instead of a straight line. So remember that non-constant rate happens when there's a curve. So in this case, we have a line that's curved. So all we need to know is that this is not constant and it's something we'll talk about next semester. So using the table below, we're going to answer the questions about this graph. So we have the words not constant, constant, 0, faster, slower, positive, and negative. So section A represents a rate of change that is 0 because it's a flat line. B, so B is going down and it's pretty steep, so that means it's going to be a constant and negative rate. C represents a rate of change that is constant and positive because it's going up. D represents a positive slope again because we're going up. However, this time it's curved, so it's going to be not constant. It's still a positive slope right now. And then for E, it's curved again and it's going down. So again, this is not constant and negative because the line is going down. According to the graph, Terrence was moving blank during this time represented by section B than the time represented by section C. So B is a really steep line, C is kind of a flatter line. So we're going to see that he was moving faster during section B than he was in section C. So let's practice finding the rate of change of graphs. So when you find the rate of change of a graph, remember you need 2 points, so they're already giving us 2 points. We know that our slope has to be positive because the line is going up from left to right. So I'm going to use my little triangle to figure out how much did I go up and then how much did I go to the right. So I went up 2 and right 4, so my rate of change is 2 over 4. Remember to always reduce your rate of change, so it would be 1/2. Number 9 for my 2 points, I'm going down and then to the right, so -1, and then 1, 2, 3, 4, 5. So my slope would be -1/5, which should make sense because the line is decreasing from left to right. Number 12, given y equals 4x minus 5, complete the table. So I'm going to put each number in for x to complete my table. So 4 times -2 is -8, minus 5 is -13. 4 times -1 is -4, minus 5 is -9. 4 times 0 is 0, minus 5 is -5. 4 times 1 is 4, minus 5 is -1. And 4 times 2 minus 5 is 3. So what is the rate of change? You can pick any 2 points in the table you want. So I'm just going to use the first 2 points. So to get from -1 or -2 to -1, I added 1. To get from -13 to -9, I added 4. So my rate of change would be 4 over 1. 13, we now have 2/3 x plus 1, and we need to complete the table. So the rate of change, 2/3 times -6 is -4, plus 1 is -3. 2/3 times -3 is -2, plus 1 is -1. 0 times 2/3 is 0, plus 1 is 1. 2/3 times 3 is 2, plus 1 is 3. And 2/3 times 6 is 4, plus 1 is 5. So we want to find the rate of change. So again, pick any 2 points. So this time I'm going to pick the 3rd and 4th point. So to get from 0 to 3, I add 3. To get from 1 to 3, I add 2. So my slope is 2/3. What pattern do you see between the equation, the table, and the rate of change? Well, if you notice, 2/3 is in front of the x here. If we look back at our other problem, 4 is in front of the x. So what do we notice? The rate of change of the table is the number in front of x. Remember, that is called a coefficient if it's a number in front of a variable. So let's explore rate of change a bit more. So every fall, Merino Community Center must empty the water in their pool as they prepare for cold weather. So it's going to take them 8 hours to enter their pool. So we're going to see what the volume of the pool is at every 2-hour interval. So it started at 1,200 gallons and then went to 900, 600, 300 until it was finally empty at 0. So what we want to do in the first part is we want to find rate of change at 3 instances. So we're going to pick 3 different set of points. So let's pick this one. So to get from 1,200 to 900, we went down by 300 and we went up by 2. So negative 300 divided by 2 is negative 150 gallons per hour. Make sure that we're giving a unit here because we have one. Let's pick 2 more points. So now I'm going to pick 2 and 6, 900 and 300. Make sure that you're picking the entire row that you use. So 900 to 300 is minus 600. 2 to 6 is plus 4. So we have negative 600 over 2 or over 4, which reduces to negative 150 gallons per hour. And we're going to pick one more point. So let's pick 6 to 8 and 300 to 0. So minus 300 and plus 2. Negative 300 over 2 is equal to negative 150 gallons per hour. So what do the 3 rates tell you? Well, all of our rates that we found were the same, so we have a constant rate of change because all rates were the same. Does the negative rate of change make sense in this situation? Well, in this case, remember that they were emptying the pool, so it should make sense because they're emptying a pool. If the rate of change was positive, what would it mean in this situation? Well, if it's negative, we're emptying the pool. So if it's positive, we would be filling the pool with water.